Standard 11 Chemistry Unit 4 Chemical Bondings and Molecular Structure Part 18. Today we are going to learn about energy level diagram for molecular orbital. First of all, let's see the energy level diagram. For the energy level diagram, as we have already discussed about various electronic configuration for the various atoms. For example, here suppose for oxygen and its atomic number is 8. Its electronic configuration is 1s2, 2s2 and 2p3. Or for hydrogen atom, its electronic configuration is only 1s1. Now the energy level diagram, we have two energy level diagram. The molecular orbital diagram for 14 or less than 14 electron system. For example, here a nitrogen molecule formed by two nitrogen atom, and here the 7 electrons present in the one nitrogen atom, so 7 plus 7 equal to 14 electrons. Or here the for hydrogen molecule, two hydrogen atoms are combined, there are 1 plus 1 means 2 electron. So here the molecular diagram for 14 electrons system, and second is the molecular orbital diagram for greater than 14 electrons system. That means here, for example, for an oxygen at molecule combination, two oxygen atoms are combined. Here the number of electrons present in one oxygen atom is 8, so 8 plus 8 equal to 16 electron is greater than 14 electron system. And from this data, the number of electron present in bonding orbitals, NB, that means number of electron present in bonding orbitals, and Na, the number of electron present in anti-bonding orbital. Here the electronic configuration and the molecular behavior. The stability of the molecule is depends upon the number of electron present in bonding molecular orbital and the anti-bonding orbital. The number of molecule is stable if Nb minus Nb is greater than Na, and the molecule is unstable if Nb is less than Na. And second is most important, another thing, the bond order. Bond order is defined as the one half of the difference between the number of electrons present in bonding and anti-bonding orbitals. Bond order is equal to half Nb minus Na. So how we can calculate the number of electrons present in bonding and anti-bonding orbital? For this calculation number of electrons, let's see about the energy level diagram. Now the diagram, molecular orbital diagram, for 14 or less than 14 electron system. Here is the atomic orbital for 1s. Is 1s at orbital for the another atom. Here is atomic orbital, is also atomic orbital, is bonding orbital, is BO, and it is anti-bonding molecular orbital, is ABMO, or it is BMO, bonding molecular orbitals. Okay, is for 1s. Now for 2s orbital, here the another. Now on increasing, according to the increasing energy level, then after 1s, 2s, and then 2p. Here the for 2p there are three suborbitals, px, py, and pz. Px, py, and pz for 2p orbital. The and here for another atom, its atomic orbital is px, py, and pz. Now is a bonding molecular orbital for is sigma 1s. Here the sigma 2s, and here the pi 2px, and it is pi 2py, and this sigma 2pz. Now the antibonding molecular orbital sigma 1s is sigma antibonding 1s, then sigma antibonding 2s, and here is pi to px, pi to py, pi to py. Oh, here the pi anti-bonding to px, and this pi anti-bonding to py, and here is sigma to pz, this sigma anti-bonding to pz orbital. This is the molecular diagram for 14 or less than 14 electron system. Now the energy, order of energy here, sigma 1s is less than sigma antibonding 1s. Then after sigma 2s, it is less than sigma 2s is less than sigma antibonding 2s is less than, now pi to px is equal to pi to py. That means their energy is nearly about same. Then it is less than sigma to pz is less than pi antibonding to px equal to pi antibonding to py. Then it is less than sigma antibonding to pz, sigma antibonding to pz. Is the order of energy. Now let's see how many number of electrons present in the bonding orbitals and the antibonding orbitals. For example, nitrogen molecule, nitrogen molecule, its atomic number is 7. Its electronic configuration is 1s2, 2s2 and 2p3. Here the total number of electrons are 14 electrons. So this diagram will help us for find out the number of electron present in bonding orbitals and number of electron present in antibonding orbitals. Here for nitrogen atom there are 2 electrons present in 1s orbital. Here the for another nitrogen atom in 1s orbital there are 2 electrons. Then after in 2s orbital there are 2 electrons. For another in nitrogen atom there are 2 electrons. Then in 2p orbital there are 3 electrons present in 2p orbital. It is singly occupied. There are 3 unpaired electrons. Okay. Now the bonding orbital, 1 electron from the 1s orbital and here from the 1s orbital, and the 1 electron from here, so total 4 electrons. Then after same condition is here for one electron, for one electron for antibonding 2s. Then it's very most important here the px, or from px it's 1 electron and from this 1 electron present, py 1 electron and here pz, and 1 electron from the pz and 1 electron from the another pz orbital. Now we have no more electrons, so this will be remains empty. Now the calculation for the number of electron present in bonding orbitals. These all are sigma 1s, sigma 2s, pi 2px, pi 2py, sigma 2px, 2pz. These all are bonding orbitals. These all are bonding orbitals. So number of electron present in bonding orbitals are 2 plus 2 4 plus 2 6 plus 2 8 and plus 2 10. Total number of electrons is 10. Now number of electron present in anti-bonding, here 2 plus 2 4, then nothing. So total number of electron present in anti-bonding orbitals are 4 electrons. Now the bond order is equal to Nb minus Na is equal to 2. Here the 10 minus 4 divided by 2 is equal to 6 divided by 2 is equal to 3. So bond order of nitrogen molecule is for nitrogen molecule. Its bond order is 3. And second thing is very most important, the stability of the molecule. Here if Nb is greater Nb, the number of electron occupying bonding orbitals, and Na is the number of occupying anti-bonding orbital. Here Nb is greater than Na, that means it is stable molecule. Nb is less than Na, it is unstable molecule. Okay, so here the Nb is greater than Na, and that's why the nitrogen molecule is stable. Now the molecular orbital diagram for more than 14 electron system. Here the atomic orbital, this 1s, this 1s, is for 2s orbital, here for 2p orbital, px, py and pz. Px, Py, Pz. Now this atomic orbital is antibonding molecular orbital, and it is bonding molecular orbital. Sigma 1s, sigma antibonding 1s is sigma 2s, sigma antibonding 2s, and here is sigma 2pz, and it is pi 2px and pi 2py. Here the pi antibonding 2px, pi antibonding 2py, and it is sigma antibonding 2pz. Is the energy level diagram. Is little bit different from the 14 or less than 14 electron system. Okay, now the order of energy. Here we also is increasing energy. First of all, sigma 1s is less than sigma antibonding 1s is less than sigma 2s is less than sigma antibonding 2s is less than. Now sigma 2pz is less than. Here pi 2px equal to pi 2py is less than. Pi antibonding 2px equal to pi antibonding 2py, and it is less than sigma antibonding 2pz is the order of energy. Now let's see the example about oxygen molecule. Here for oxygen its atomic number is 8 and number of electrons are present in oxygen molecule 8 plus 8, total 16 electrons. Okay, so this diagram will help us to how many electrons are present in bonding orbitals and the electron present in antibonding orbitals. Suppose here the nitrogen molecule there are 14 electrons present. This diagram which will be not help us for the number of electron present in bonding orbital and the number of electron present in antibonding orbitals. So this is not for 14 electrons or less than electron, 14 electrons. Now let's see for the oxygen molecule, its electronic configuration is 1s2, 2s2 and 2p4. Okay, so in 1s orbital there are 2 electrons for the oxygen atom, and the another oxygen atom, 2 electrons. Here the 2 electrons present in 1s and 2s orbital, and then 4 electrons present in 2p orbital, 1, 2 and 3 and 4 electrons. Then same is condition is here, the 4 electrons. Now the electron here, the 2 electrons for sigma 1s and 2 electrons in antibonding 1s. Here the same conditions. Now the most important here, the sigma 2pz means the 2 electrons, and now for pi 2px, 1 electron, 1 electron, and the pi 2py, 1 electrons, and now remaining 1 electron from 2px is entered into pi antibonding to px, and 1 electron from the pi antibonding to py. Now the number of electrons present in bonding orbital, 2 plus 2 4 plus 2 8 plus 4 12 electrons. Sorry, here if 2 plus 2 4 plus 2 6 and total 4 electrons. Sorry, so here the 10 electrons, and then number of electron in antibonding, 2 plus 2 4 plus 2, total 6 electron. Now the bond order equal to Nb minus Na divided by 2. Nb is 10 electron, and here Na is 6 divided by 2. 4 divided by 2 equal to 2. So for oxygen molecule, its bond order is 2. And here second thing is, here the Nb is greater than Na, and therefore oxygen molecule is stable. Okay, this is the concept about the molecular diagram, and next time we will discuss another topic. Thank you very much.